Hello everyone, welcome back to my Chem Corner. So in today's video, we're going to discuss about the in-text questions in the chapter Solid State. So if you're new here, please don't forget to subscribe to the channel and hit the bell icon so you receive notifications as and when I upload the video. So without further ado, let's move into the in-text questions from the chapter. So the first question here is, why are solids rigid? So if you want to look at why are solids rigid, first understand how the solids are arranged. The solid particles are arranged in a three-dimensional shape. So as we can see, each of these solid particles, however their arrangements are, they're all touching each other. So in this case, the constituent particles have two things. One is a strong attractive forces because they're very close to each other, and the other one is they have very less interparticle distance. So if you look at these two diagrams, where though the solid state, the arrangement of the particles in the solid state are different, they still have very less interparticle space, which means each of these atoms really have no distance between them, and they have a very strong attractive force. So in this case, solids cannot move freely. What else can they do is they can only vibrate about their mean positions. Wherever they are, the only movement that they can have is vibration. And therefore all solids are rigid in nature. So that's how you can answer this based on the question asked. Next, in the question 1.12, it says, why do solids have definite volume? The theory of this question is also similar to the previous one. We're going to talk about the interparticle distance and the strong attractive forces which are responsible for the way the particles are arranged, and because of that, they can only vibrate about their mean positions. They cannot move freely. Therefore, solid particles are rigid as well as they have a definite volume because of all this. So for 1.1 and 1.2, the answer is the same. There's no difference in it. Now the next one is, classify the following compounds as amorphous or crystalline solids. They've given certain compounds here. One is polyurethane, then they have naphthalene, you have benzoic acid, we have Teflon, we have nitric potassium nitrate, we also have cellophane, PVC or polyvinyl chloride, fiberglass or copper. So for this question, before we move into finding the answer, which one is going to be amorphous, which one is going to be crystalline, we learn a little about amorphous and crystalline solids, and then we will move into. Now, when we learn the chapter, we all know that we have two types of solids. One is crystalline, amorphous. The same thing we're also doing in practicals in chemistry, where we are given a crystalline or an amorphous solid and asked to identify the salt. So we actually know how they look practically also. So here, under crystalline solids, what do we get? We get elements or we get compounds, right? But what about amorphous solids? They are normally polymers or mixtures. Now, what are polymers? Whenever we look at plastic, we look at fiber, we look at rubber or glass, all of these are coming under polymers. All right. So here, when we are talking about how to classify a certain list of compounds or items under crystalline or amorphous solids, look at this particular classification. It becomes easier for us to classify each of this. So here, when you're looking at polyurethane, the term poly itself means a compound is under polymer. So if it's a polymer, then it has to be an amorphous solid. Now the next one is naphthalene. Naphthalene is a crystalline compound. It is a compound. Naphthalene is an aromatic compound, so it has to be crystalline. Now the next one is benzoic acid. Again, these are all salts that are there in our lab itself. Therefore, they are crystalline in nature. They are compounds. Then we have Teflon. Teflon, we all know these are all polymers. They're all plastics. So these come under amorphous substances. Then we have potassium nitrate, which is crystalline. These are all salts available in the lab. So they're classified as crystalline solids. Cellophane is again a polymer. Therefore, they're classified as amorphous solid. PVC is also a polymer, polyvinyl chloride. Therefore, they're amorphous. Fiberglass is amorphous again. They're again coming under polymers. And copper is a metal or an element. Therefore, it's coming under crystalline nature. So you'll be able to classify whether a given compound is amorphous or crystalline based on this particular classification that you know. Crystalline solids, you generally have elements or compounds. Amorphous solids are polymers or mixtures. Now the next one is 1.4 question. The question says, refractive index of a solid is observed to be the same value in all directions. Comment on the nature of the solid. Would it show cleavage property? So here, when we learned about differences between amorphous and crystalline solid, refractive index was one of the things that was telling us the definition for anisotropy and isotropy. Under that, we learned that these physical properties, when they are measured along a particular direction, then it would give a certain value. If it's measured in a different direction, depending on whether they're crystalline or amorphous, they would give different values. So based on that, we are going to learn right now. But remember one thing, that refractive index is a physical property. So it is in the presence of light, which means it's a physical property. So when we try to measure them in different axes or different directions, say I'm trying to have a compound, I'm trying to measure refractive index along x-axis. It is giving me a certain value. If I'm measuring along y-axis, based on the question, it has to give me the same value. If I'm measuring along z-axis, it is supposed to give me the same value. That is the type of question that we're focusing on right now. Alright, so here, if a physical property has the same value along different directions, then such kind of a nature is called as isotropic nature. And we learned under properties that if a solid has isotropic nature, such kind of solids are amorphous solid. So the first question here, it is clearly, we have cleared it out, that comment on the nature of the solid, it is amorphous solid because they are isotropic, which means if physical properties measured along different directions will have the same value. Now the second question clearly asked here is, would it show a cleavage property? Now what do you mean by cleavage property? Any salt that you take in lab, if it is, say, if it is it is in a ball shape or something, when you cut it, if it is a crystalline solid, it would give you a clear edge surface. But for example, if I'm taking a chalk and I'm doing that, whenever you can also try this in school. Take a chalk and try to break it or try to cut it. When you cut it, what happens? It is not going to give you an even surface. If you see closely, you will find that the surface are quite uneven, which means there is no proper cleavage property. Amorphous solids belong to such kind of compounds where when we cut it using a sharp tool, it does not give a clear edge. So here, amorphous solids, when cut with a sharp tool, they do not give a regular surface, they will give irregular surfaces. Therefore, amorphous solids do not show a cleavage property. So till here it answers your first question. The second question is talking about the cleavage property. Basically, when you cut them, what happens? Are they going to show any cleavage property or no? Now the next question is, classify the following compounds in different categories based on the nature of intermolecular forces operating on them. And there are certain examples given to us, which is potassium sulfate, tin, benzene, urea, ammonia, water, zinc sulfide, graphite, rubidium, argon, silicon carbide. Now here in this classification, if you need to know what belongs to where, first you need to know what are those classifications. Otherwise, it is not going to help. So based on intermolecular forces, we had learned a table itself. Like in one of the videos, I had explained it. If you have not seen it, please go ahead and see. There are a few videos behind where I've explained clearly in detail about this particular chapter, each topic. So please go through it, then you will be able to answer these. So before we solve this question, we'll first see what are those intermolecular forces on which solids are classified. So here we have ionic solids, metallic solids, and we also have covalent and molecular solids. Alright, so we have 4 types of solids here: ionic, metallic, covalent, and molecular solids. 4 types of solids are there. Ionic solids meaning our constituent particles are going to be ions. If you're talking about metallic solids, your constituent particles are going to be metals. If you're talking about covalent solids, you're going to talk about your constituent particles being atoms. Or if you're talking about molecular solids, your constituent particles are going to be molecules. So depending on that, you can identify by looking at these examples. So potassium sulfate, they are ionic solids because you can get potassium ion and sulfate ion, ionic solid. Tin is just a metal, therefore they are metallic solid. Benzene is a molecule, therefore they are molecular solid. Similarly, urea, ammonia, water, they are all molecules, so they are classified under molecular solid. Zinc sulfide, you can get Zn2 plus separate and sulfide separate, therefore they are ionic solids. Graphite, we all learned last year that graphite, when we look at the structure itself, the bonding there is covalent, therefore they're covalent solids. Rubidium is a metal, therefore they're metallic solid. Argon comes under noble gases, they're molecule by itself, therefore they're molecular solid. Silicon carbide also we learned last year, therefore they're called as covalent solids. So if you can identify the nature of these um, compounds or elements, you'll be able to classify them based on the intermolecular forces between them, and you will have your answers right. So before you try to solve such questions, better know what these classifications are, so it becomes easy for you all to answer such questions.